this is going to be under half an hour, and so here it goes. We only are doing the it's a very basic laser safety training, which is required by the state, so that everyone at Laxarcan Light Scalpel is trained and as required per, say, Washington state regulations. And Washington State did audit us, and they did approve our addition to our standard operating procedures as far as the laser safety. They did approve this specific laser safety training, including the quiz that is a part of this laser safety training. So the quiz has 6 questions. It's page 11, and either as I go, you can fill it. You can fill in your answers, or at the end of this half-hour presentation. Okay. So, Light Scalpel Laxarca is the medical device manufacturer, and we are not a healthcare facility. So this is where the full-blown laser safety regulations applies to us. And so laser stands for the light amplification by stimulated emission of radiation. Lasers are used pretty much across industry, military, science, medicine, telecommunications. CD player has the pretty powerful laser inside of it, as a good example. And the laser beam it's a single wavelength. They are monochromatic. They are highly directional, and the hazard, laser beam hazard, is all about the laser beam being directional or collimated. As far as the monochromatic or coherent, this is the fancy talk, but the danger comes from the beam being collimated. And so here's the good example of the laser. This is the laser that we make. A long story short, you need to have the 2 mirrors. You need to have an active medium in between the 2 mirrors. And if you get it all done right, and quote-unquote right, it would be in a couple of years laser course. So if you do this right, then you have the laser beam coming out of this contraption. And the most important features of the beam is it's focusable. We cannot really focus the light out of the ordinary light bulb, but this is the whole idea of the laser. We can focus the collimated directional beam from the laser into the smallest physically possible focal spot, which is unattainable with the ordinary light sources. And this is where the danger is coming from. Applications, the bulk of the applications are industrial, medical, and the military, just small peanuts as far as the volumes. And the industrial lasers, medical. This is how the laser looks on the inside, and as long as the laser is properly enclosed with all these covers, electrical hazard is the same like a toaster or the coffee maker. You just don't stick your fingers inside of that machine. But if the covers are off, so this is where the full-blown laser safety consideration comes in as far as the laser beam and the non-beam laser hazards. Important little nuance for we will discuss the nominal ocular hazard distance, which is the distance outside of which there is no laser beam hazard present. And an interesting practical consideration for our users who use the handpieces like shown, the nominal hazard distance is less than 1 foot for typical laser settings that they are using. So this is to say that the laser beam hazards are not something that like from here to the moon. It's all based in the design. And for our handpieces, it's all about how fast the laser beam is being defocused. And if it's defocused fast, like in our lasers, then the nominal ocular hazard distance could be super short, inches. So the laser safety regulations are not reinvented by users. They are created by the American National Standards Institute in cooperation with the Laser Institute of America, and the NC Z136-1, that's the one that is applicable to us as the manufacturer and the user of the lasers. So laser safety classifications. The class 1 is the laser where the beam does not make out of the box. So there is no laser beam hazard present, period. Great examples are laser printers and the CD players. The most dangerous laser is class 4, and the beam hazard danger is defined simply by how much power does the laser have. And the class 4, this is greater than 4 watts. However, here's an important nuance. So online you can buy yourself a laser pointer, and some of these laser pointers would be class 2 or class 3. And if you point that laser pointer at the jetliner, people do go to prison. There are federal laws on the books. So how come you can buy the laser over the internet, no laser safety training, and people do go to prison? That's for you. And now you have the class 4 laser, seemingly the most powerful. Then there are full-blown safety regulations applicable to the facility. So all this really says that if you know what you're doing, the laser's not only useful, but they could be incredibly safe. In a nutshell, for our customers, they comply with the laser safety regulations if they have the 3 simple laser safety measures in place, which is they have the laser safety officer appointed, they have the laser in use sign, and they have the laser safety glasses available for the personnel where the laser being used. So if you think about the hundreds of pages of the regulations, and all this is reduced down to just the 3 simple measures, then you can comprehend that if you know what you're doing laser safety-wise, this can really be safe and enforced in a very simple way. The laser safety hazards are something that is defined and approved by the laser safety officer, and for our facility we do have the laser safety officer, that's me, and I'm the one who issues the laser safety amendments to our standard operating procedures, which includes the laser safety training, and this all is approved by the state of Washington. And the laser safety hazard definition and evaluation starts with so what kind of laser do we have? And we are not really looking at the laser printers. We're looking at the lasers at our manufacturing facility. And the answer is very simple, class 4. Then we also determine which wavelength, 10.6. This determines that the laser beam hazard is the skin burn and the corneal burn, but not the retinal burn. Important concept with the lasers is not just the power, this is what the class 4 classification comes in, but also the nominal hazard zone or the nominal ocular hazard distance and the maximum permissible exposure. The maximum permissible exposure, this is the watts per square centimeter, and so this is pretty much the power density, and this is the power density at which there is absolutely no risk of the corneal burn or the skin burn. So pretty much, in a very practical terms, if you don't feel it, there's nothing to worry about. And now the definition of the nominal hazard zone or the nominal ocular hazard distance, this is the distance and the zone outside of which there is no laser beam hazard present. And the laser beam hazard is defined as the power density greater than the maximum permissible exposure. So for our manufacturing, the nominal ocular hazard distance is it's in the range of I think it's several hundred feet. So the distance is great. So that's why we have our laser beams confined inside of the workbenches with the laser beam dumps, the big bricks that we are using. By the way, certified by the state as the appropriate laser beam stops. So, as far as the laser safety control measures, there are engineering controls. So the laser beam stop will be classified as one of the engineering controls. Personal protective equipment, which is the laser safety glasses. And the administrative controls, which is the laser safety training that we are doing right now, and laser in use signs. For our workplace, we need to have the personnel trained. We need to have the laser in use sign displayed, and we need to have the laser safety glasses used. And so right now the laser safety glasses are required to wear in the service area. The service area is secluded by the wall in front of it. Then as far as the manufacturing, the final test area is designed to enclose the laser beam inside of it. And so pretty much for anyone working in the production outside of the final test, it is laser safe. There is no laser hazard there present. Subject to there is some fine-tuning going on in the final area, in the final test area. So then there are also the electrical safety, fire safety, which are also part of the laser safety regulations, and they are pretty much reduced to the point of the don't stick your fingers inside of the laser consoles, and don't shoot the laser at the flammable materials like a piece of clothing, for instance. So the way the skin burn and the corneal burn work is, it's all about the thermal damage. The laser energy, like any energy, it converts ultimately into heat, and that's why it's the thermal damage. For the lasers, like the laser pointer or the near-infrared lasers, when the laser beam can go through the water, such laser beam will go easily through the eyeball and inside of the eyeball there is a focusing lens, and the collimated laser beam, like from the laser pointer, will be focused by the lens on the retina. So seemingly low power laser beam can do some pretty major damage on the back of the eye, the retina, and the danger originates all because of the collimated nature of the beam. For the lasers that do not go through water, like the surgical CO2 laser, the retinal damage is just impossible, but the corneal damage and the skin burn damage is not much fun. Both the corneal damage and the retinal damage in the hands of the knowledgeable doctors, surgeons, actually those are the laser surgeries sold to us, the public, at a great benefit to us and a good profit for the doctors. Great example is the skin resurfacing, or in the dental applications that we sell our lasers for, the applications like the after ulcer treatment, for instance. Just a very little blanching on the lesion does the great job. Thermal damage, absolutely. Does it have the positive effects? Absolutely. And as far as the biochemical effects, it doesn't really apply to any of our lasers. Our lasers purely thermal. And so now we arrive at the personal control measures, personal protective equipment, simply the safety glasses. And a quick review how exactly the laser safety glasses fit into all the big picture is the laser safety glasses are just the parts of the laser safety scene, so to speak, where there are two more important components: laser safety officer, which is me, a laser in use sign that we have posted throughout where the lasers are used, and the laser safety glasses. If you enter the final test area, take the glasses, wear them, enter. And same with the laser, was the service area. Our personnel is required to wear the laser safety glasses where we are working on them. Not all people here in the training are working with the lasers. So there is the one important nuance for the people who work in the, say, in the laser safety, in the service department, like Tony and Ken. Who else? No, just you two guys. So the state, the Washington state, made a pretty big deal about having the laser in use sign on this yellow plastic chain, blocking the workbench when we have the laser going through the burn-ins, the shutter test, or whatever the long term. Only if that station, that workbench, is unattended. If it's attended, you don't need to have the chain with the laser in use sign. Only when you are leaving, and the test takes say half an hour, 40 minutes, some of these tests are long. This is when state requires us as the company to have this very specific for lock, socket, and light scalpel laser safety measure. So what makes the laser safety glasses legal is the marking on them. It's the wavelength, and that's also the optical density. Optical density shows how many thousand times the laser beam is attenuated and this passes through the material of the laser safety glasses. A comment on kind of the common sense and the kind of the warm and fuzzy understanding of the laser safety glasses. With respect to the CO2 lasers, you pretty much can say that's the close to maybe 100% of the naturally occurring materials and even the man-made materials around us, they all block the CO2 laser light, like the window glass, like the reading glasses, like the glass in that door. And the laser safety regulation specifically states that the ordinary glass, window glass, thicker than 3 millimeters, is considered as appropriate safety shield for the CO2 laser light. The plastic in the laser safety glasses, it's a polycarbonate acrylic glass plastic. It's a garden variety safety glasses from the Home Depot, $10. What makes them legal is the manufacturer, the vendor, that they do whatever tests they do. They put the labels on it, and all of a sudden that becomes a $50 glass. But this common sense as to have the CO2 laser beam is blocked is, for me it helps to understand what really is the danger. And also when you understand how laser safety regulations are designed, for instance, for our medical users, it's even though they will be using the medical laser and the settings where the nominal ocular hazard distance will be, say, 5 inches. Because our lasers used at a very low power settings. But then the whole room where the laser is used is declared by the laser safety officer as the nominal hazard zone, even though the size of that room could be 20 feet by 20 feet. That everybody in that room will be wearing the laser safety glasses, and this is really the nature of how the laser safety rules and measures are designed. It's a great overkill. It's not only the distance, but this is the glasses for everybody. So under no circumstances there is any even discussions that was the possibly unsafe use of lasers, and the laser safety glasses play the major role there. Once you see everybody wearing the laser safety glasses, it's kind of the very good. Dr. Thomas has a good comment about the good lasers and not so good lasers, and actually the lasers that actually not even the lasers when they're used. So he says if you enter the laser treatment room and everybody wears dark glasses, you are in the wrong room. So this is the comment about some other type of lasers where an ordinary glass or acrylic is no longer blocking that light. Then you really need to have a special coatings, green, red, black, and those lasers are in the visible and the near infrared range. And that's the point. Just like that glass in the picture, laser safety glasses are tailored to the wavelength of the laser that is being used. And so literally, if you see the glasses and doesn't have the other wavelength, then you don't want to wear them. You need to wear only our own wavelength. So this pretty much says that for Tony and Ken, you are the closest one to the laser beam, and all it says, don't stick your hands in the laser beam, which we already know from the previous training. All right, labeling and signs, laser in use signs, and the laser in use signs could look differently, like this one or that one, and it has the danger sign. Equipment has also the laser danger sign in it, and The non-beam hazard is the big part of the laser safety consideration. And the great example is the non-beam hazard that is the everyday occurrence and a part of the life of our customers who do laser surgery. The whole idea of the laser surgery is to make the living tissue go up in smoke. You need to evacuate that smoke. In dental offices, this is the suction devices. Outside of the dental offices, those are the standalone smoke evacuators that we have. Everybody here has seen what the smoke evacuator is. And according to the laser safety regulations, there is only one way, there is only one safety measure for that kind of the non-beam hazard, and that is smoke evacuation. No masks, smoke evacuation. You really need to have a standalone, powerful device that can suck all the smoke out of the room. So this is just the point of the non-beam hazards are very significant and very important to be dealt with. And the way it applies to us, manufacturing facility and the service facility, it's the electrical hazard, because you guys have, every day you work around the exposed electrical wires, which reminds me to bring a very important point about our competitors who deal with the glass laser tubes, CO2 laser tubes. Unlike our lasers that have only 110 volts from the mains, and then we reduce the voltage to 32. The glass tube laser devices operate with the 20,000 volts. And Paul and I refused several times the offers to repair somebody else's lasers. And in case we are repairing the 20,000 volts, then our laser safety training will be shifted heavily into the electrical safety, but not so for what we do. And not only that, but also those devices, they also use water as a cooling agent. So then you have the combination of the glass, 20,000 volts, and water. This is not a very happy combination. So in our case, it's the metal that doesn't break. It's the 30 volts, which is, RF can cause the burn, but not really the electrical shock. And then the air, we cooling our lasers with the air. Chemical hazard is not really present. It's all in the medical field for some of the photodynamic therapy lasers. Doesn't apply to us. And the summary is that are they hazardous? You absolutely, big time. However, if you know what you are doing, then the lasers they can be made safe, and the safety measures are reduced down to the a simple concept of that there is a laser safety officer that enforces the laser in use signs and the personal protective equipment, and which are the glasses, and everything else is important, but not as important as these three major things. Laser safety officer. The laser safety officer is as important as if the facility gets audited and the employees do not know what the laser safety officer means. This is where the fines come in. So the state is very serious about the laser safety regulations, to the point that you don't really just want to have a formal laser safety officer. That you want to have the employees trained and aware of there is a laser safety officer, there is a safety program, you train, there is a test. So pretty much the laser safety program really needs to be burned in our brain.